This is a two-part question. Let's start with part one. And how many grams of potassium hydroxide have to be dissolved to make a 250 milliliter solution that is 0.150 molar in KOH? Let's start with what we know. We know the volume is 250 milliliters or 0.250 liters. The molarity is 0.150 molar. We don't know the number of moles. We don't know the number of grams, but if we know the number of moles, we can figure the number of grams. Molarity is moles divided by liter of solution, so 0.150 moles per liter, which is the same thing as molarity, equals moles divided by a quarter liter. Rearrange to get this, and solve, and you've got 0.0375 moles of potassium hydroxide. Moles times molar mass equals grams. The molar mass of potassium hydroxide is 56.11 grams per mole. Put those into the equation, and the answer to this question is 2.10 grams of potassium hydroxide are needed to make the stated solution. Let's go on to question 2. What is the concentration of each ion if 2.50 grams of sodium carbonate are dissolved to make 425 milliliters of solution? Once again, start with what we know. The volume, 425 milliliters, is 0.425 liters. We don't know the concentration of sodium carbonate. We do know that the concentration of the sodium will be twice the concentration of the sodium carbonate because there are 2 sodiums for every 1 sodium carbonate. The carbonate ion will be equal to the concentration of the sodium carbonate because there's 1 carbonate ion for every sodium carbonate. We don't know the number of moles of sodium carbonate, but we are given the grams, 2.50. The molar mass of sodium carbonate is 105.99 grams per mole. So we can set it up and we get 0.0189 moles of sodium carbonate. So for the sodium carbonate, molarity is moles divided by liters. So 0.0189 moles divided by 0.425 liters means the concentration of the sodium carbonate is 0.0445 molar. The concentration of the sodium is twice that of the sodium carbonate. So you multiply the 0.0445 molar by 2 and you get 0.0890 molar. The concentration of the carbonate ion is the same as the concentration of the sodium carbonate, so that stays at 0.445 molar. So in this solution, the concentration of the sodium ion is 0.0890 molar, and the concentration of the carbonate ion is 0.0445 molar.